So imagine you want to escape the solar system, but you're on a budget. To cut costs, you're going to reduce the number of rockets and fuel that you use. Just one problem. You still need to reach the sun's escape velocity. Fortunately, there's a way to steal kinetic energy from an orbiting planet. Gravity-assist maneuvers are simple. Your spacecraft will follow a curved trajectory, flying close enough to a planet to enter its gravity well and slingshot away, changing its speed and direction in the process. But wait, the law of conservation of energy states that for a closed system, the total energy must remain constant. So doesn't this violate that? Shouldn't your spacecraft exit the gravity well at the same speed it enters, sort of like how a ball rolling into a valley will first accelerate, but then decelerate on its way out? The key to understanding this is frames of reference. Consider an airplane which can have a different ground speed from its airspeed due to the wind pushing on it. In our case, there are two frames of reference, one relative to the planet and one relative to the sun. Relative to itself, the planet is stationary. In this frame of reference, the spacecraft enters its gravity well, accelerates, and then exits at the speed it entered at. But relative to the sun, the planet is moving too. So the spacecraft enters the gravity well, accelerates, and exits with speed from the planet's orbit added to its own. This only works because momentum from the planet is transferred to the spacecraft, meaning that energy is conserved because the planet actually slows down as a result of the interaction. The speed it loses is so small that it's negligible. Remember that the planet is a lot larger than the spacecraft, so the amount of momentum transferred translates to a much greater speed change for the spacecraft. Gravity assists aren't just for speeding up, though. They can also be used to slow down and change direction, making them incredibly versatile in space exploration. A notable example would be NASA's Voyager missions, which use gravity assist to help them gain enough velocity to escape the solar system. And NASA's upcoming 2024 Europa Clipper mission is also set to use gravity assist to help it reach its destination. Gravity assists have pushed the boundary of human space exploration.